Hi guys, so Learning Unit 3 really starts introducing us to the structures of proteins. And then we'll move on in the next chapter and the next learning unit to talk about how structure really affords function, and we'll look at a couple of key proteins. So this learning unit really comprises three chapters in your textbook. So it's chapter 4 on amino acid structure and derivatives, it's chapter 5 on primary structure, which is really sequence of proteins, and then chapter 6, which is really secondary, tertiary, and quaternary structure, which are all three-dimensional structures of proteins. So just to kind of highlight a few of the nuts and bolts that we'll spend some time talking about, in chapter 4, we've been spending so much time learning our amino acid structures, so that's not something we'll spend a lot of time in class, but we'll talk about sort of the chemistries that can happen between the functional groups that are present on amino acids. So we'll talk about the amino and the carboxy termini, which really allows us to do that connecting chemistry and create that peptide bond to make proteins. We'll also talk about the chemistry that can happen between side chain atoms, so specifically thinking about things like the amino acid cysteine, and so the chemistry that can happen when we form disulfide links. And we'll put that in the context of a really important cysteine-containing peptide in glutathione, one of your very important biochemical antioxidants in your body. We'll move on then in chapter 5 to talk about primary structure, which is really just the sequence of proteins. We'll spend a little bit of time sort of talking about kind of some minimum and maximum sizes of proteins, what we want to think about with regards to that. We'll think about kind of the diversity that we see in nature and talk about kind of some limits just from a probability standpoint of investigating every possibility and how nature really finds motifs. And then we'll kind of talk about how proteins are sequenced, what information we get when we sequence a protein, and then we'll talk about how those sequences kind of can evolve and what it means if a protein sequence really isn't evolving much over time and how that translates and relates to the function of proteins. Then we move on to chapter 6 where, like I said, we talk about three-dimensional structures of proteins. And really we're talking about secondary, tertiary, and quaternary structure. And the difference between all of those really is who's interacting to be part of that structure. With secondary structure, it's backbone atoms. With tertiary structure, it's side chain atoms within a protein subunit. And then for quaternary structure, which doesn't happen for every protein, it's really interactions between side chains between protein subunits. So we'll have a lot of this kind of discussion of inter, meaning between, or intra, meaning within interactions in protein structure. So we'll spend some time talking about what proteins look like. We'll talk about very simply at the beginning the peptide group and what we need to think about in terms of that structural kind of linking unit and how that relates to kind of allowed conformations for proteins. We'll kind of have a general theme that we'll talk about protein structure happens because we need to think about sterics and energetics. We don't want things banging into one another, and we need to think about entropy-enthalpy compensations. So structure formation is entropically unfavorable to kind of freeze something out and have no molecular motion or limited molecular motion. So we compensate for it by enthalpy or intermolecular forces. So we'll kind of talk about how that all kind of comes into play, kind of this concept of sterics versus energetics as being a driving force for structure. We'll break apart and talk about secondary structural elements, so we'll learn about alpha helices and beta sheets. We'll talk about how we distribute side chains among both of those secondary structural elements. We'll talk about two really important proteins that are fairly simple in terms of their secondary structural elements. They're largely alpha helical, so we'll talk about keratin and collagen, and importantly, thinking about supplementing with collagen and some things that you might want to consider if you want to supplement with collagen. We'll spend a little bit of time just kind of understanding how structures are determined, so X-ray crystallography, NMR, spectroscopy, and how that structural information can kind of become important as a research tool. We'll talk about then what holds tertiary structures together and talk about the difference between stabilizing and specifying forces. And then we'll actually talk about how we can predict structure. We'll talk about how proteins are folded and kind of the dynamics of protein folding, and then at the very end kind of wrap up with a discussion of what happens when proteins misfold. So we'll actually spend probably 2 to 3 lectures talking about some important proteins, not only their structures, but what happens when those structures are not correct. So we'll talk about insulin. We'll have a case study that we'll talk about with insulin. We'll talk about the protein gluten and kind of what happens with this whole kind of gluten situation and what we need to think about with regards to that. And then we'll talk about Alzheimer's disease. We've already talked about Alzheimer's in the context of people who are ApoE4 and kind of their increased risk for Alzheimer's disease, and that has to do with the decreased ability to clear these A-beta amyloid plaques that form. So we'll learn about what the structure of those proteins are, how they form, how this ApoE kind of comes into play there. And so we'll kind of bring a lot of these pieces together with this last learning unit that you'll have before your first test.